Welcome everyone. In this video, we are going to learn about the indices and the rule of indices. This is the learning outcome for this subtopic. If a is a real number and n is a positive integer, then a to the power of n equals to the multiplication of a about n times, where the number of a is called as the base and n is called as the index or often called as power. This means that the index of a number says how many times to use that number in a multiplication. It is important to know the rules of indices before we go further. The rules of indices are often used to simplify expression and to solve equations involving indices. The first rule is the multiplication rule. If there are two terms that have the same base and are to be multiplied together, their indices are added. For example, 2 cubed multiplied by 2 squared is equals to 2 to the power of 3 plus 2, which then can be solved to 32. The second rule is the division rule. If there are two terms that have the same base and are to be divided, their indices are subtracted. The example is 2 to the power 5 divided by 2 squared is equals to 2 to the power 5 minus 2, and then simplify the power and you get the answer 8. The third rule is the brackets rule. If an index a to the power of m raised to the power of n, then the powers are multiplied together and equal to a to the power of mn. For example, a squared raised to the power of 3 is equals to a to the power of 6. The next one is the power of 0. Any base with power of 0 is equals to 1. So the answer for the example is absolutely 1. The next one is the negative power. A to the power of negative n can be written as a fraction 1 over a to the power of n. The example is 2 to the power of negative 3. This can be written as 1 over 2 cubed, which is equals to 1 over 8. Next is the fractional power. There are two types. One is a to the power of 1 over n, and the other one is a to the power of m over n. For a to the power of 1 over n, this index can be expressed as a surd. We say it as the n root of a. The example is 4 to the power of 1 over 2, which can be expressed as square root and equals to 2. For a to the power of m over n, both the numerator and denominator of a fractional power have meaning. The denominator of the fraction stands for the type of root, and the numerator gives the power of the whole term. For example, 8 to the power of 2 over 3 is equals to cube root of 8 raised to the power of 2. We solve the cube root of 8 first, which is equals to 2, and then raised to the power of 2. Then the answer is equals to 4. The next rule is when the base is multiplication of two different terms, a and b. The power n can be distributed to both base and equals to a to the power of n multiplied by b to the power of n. For example, xy cubed is equals to x cubed y cubed. And the last rule is when the base is a fraction a over b. Just like the previous rule, we can also distribute the power to the numerator and denominator. So this is equals to a to the power of n over b to the power of n. The example is 3 over 5 cubed, which then can be solved and equals to 27 over 125. So this is the exercise. Question 1. We want to simplify all of this expression. 1a is to simplify 3 power of 5 multiplied by 3 power of 6 divided by 3 to the power of 4. Since the indices are of the same base, so we can apply the multiplication rule and division rule since it involves both multiplication and division. So we will solve the numerator first. Since it involves multiplication, so we add the power and the power becomes 11. The next step is using the division rule where we subtract the power and then calculate to find the answer. Or we can also use the alternative method where we directly combine both rules. For question B, we want to simplify 18x squared y to the power 5 divided by 3x to the power 4 y. Since this involves fraction, so we use the division rule for variable x and y, where we subtract the power. Meanwhile, the 18 and 3 can be simplified to 6, and we get the answer in index form. Because there is negative power, so we can state the answer in fraction as well. For question 1c, this involves the bracket rule, where we multiply the power. Since the base are multiplication of 3 and x to the power 5, so we distribute the power of 2 to both 3 and x to the power 5, and we get the answer 9x to the power of 10. Question 2 is, write the following expressions in index form. For question 2a, we can directly change this expression to index form and the power becomes negative. For question 2b, we use the bracket rule where we multiply the power and we get x squared. For question 2c, we solve the radicand first, which means the expression inside the cube root, and it will become 27x cubed, and change the cube root to power 1 over 3. Then, change 27 to index number 3 cubed. After that, distribute the power 1 over 3 to 3 cubed and x cubed inside the bracket, and we get 3x. So question 3 is, without using calculator, evaluate A and B. Question 3a is 9 to the power of negative 3 over 2. We know that 9 can be changed to an index number 3 squared. So we change it to 3 squared first. Then apply the bracket rules and we get 3 to the power of negative 3 and solve it until you get the final answer. The final answer must be in the simplified form. You cannot leave your answer as 1 over 3 cubed. Question 3b is a mixed number raised to the power of negative 1 over 2. We have to change this mixed number to improper fraction first. Then 36 over 25 to the power of negative 1 over 2 can be written as 36 over 25 to the power of negative 1 raised to the power of 1 over 2. And 36 over 25 to the power of negative 1 can be expressed as a fraction 1 over 36 over 25, which then become 25 over 36, and the power remain the same, which is 1 over 2. Since 25 and 36 are both squaring numbers, so we can express it in index form. Then by using the bracket rule, we can multiply the power 1 over 2 to the power of numerator and the power of denominator, and we get the answer 5 over 6. Question 4a is to simplify this given expression. For this expression, there are 4 variables that we have to simplify. So first, we have to distribute the power of 3 to every term in the first fraction, and we get this new expression. So now we can apply the multiplication and division rule for variable a and variable x, since both variables involve division, so we subtract the power. Variable b involves multiplication, so we add the power. variable y appear as denominator, so we can write it in index form, where the power become negative. By solving this, we can get the answer in index form, or we can also express it in fraction. Question 4b is to simplify this expression. First, we multiply the power. Then apply the multiplication rule for 2 to the power of 2n plus 4 and 2 to the power of 2n minus 2, which then become the expression in maroon color. 2 to the power 4 is equals to 16, and the multiplication of 24 and 2 to the power of negative 2 equals to 6. The numerator of this expression has a common factor 2 to the power of 2n. We can factorize this common factor and leave 16 minus 6 in the bracket. Then simplify and we get the answer 1. Please submit this exercise to your lecturer before class ended. Thank you.